Hi, in this tutorial we're going to see how to make a custom FK-IK setup for extra limbs. As I'm sure you know, in MotionBuilder, the main rigging system, human IK, is perfect for creatures or characters with 2 pairs of legs and 2 arms. So if you have extra limbs, such as here for some kind of wings, or maybe arms that stick out of the abdomen, or a second pair of legs or anything, we're going to have to make a custom setup. So this video is going to work as a little summary of things we've seen in previous videos, such as creating your own controllers, adding them to character extensions, using the relation constraint to set up our system, as well as other constraints. And for the IK particularly, we're going to set it up in a way that allows you to fix potential yaw rotations on the elbow, so broken rotations on the elbow. That's like the special feature we're going to make here. So I have this character here that's already characterized in human IK with those controllers, and I have 2 series of bones that are part of the main skeleton. They're just children of this skeleton here. So 2 wing arms kind of thing that are parented to spine 03. So here the last bone of my spine. So currently they're just AFK bones that will rotate with the rest of the character like this. No special rig just yet. So the hierarchy is like so. There's a clavicle, which is skinned to nothing here. And then there's for each arm an upper arm and a lower arm, which are the parts that interest us the most here for the IK setup. And then there's just a hand at the end. So potentially your rig maybe has like extra fingers or anything like that. And we have some twist bones here that here I don't think they're skinned to anything, but those twist bone you could rig with what I showed in the twist video. So not gonna spend much time on these. So the first thing you might want to do is create a second FK hierarchy, but controllers, not just bones, because it's not ideal to animate directly on the bones. So we're going to create a bunch of markers that are going to have a similar look to the human IK FK markers or controls. So going to Asset Browser, Elements, going to add markers like this. We're going to line them up to each of the main bones that we care about. So clavicle, upper arm, lower arm, and hand. We're not going to worry about the twist bones, and in fact I'm going to just hide them for the rest of the video. Make them size 0, for example. So marker. Here it is. Marker. So I'm gonna immediately change its look. I'm gonna use stick, for example. Make it a little bigger, and I'm gonna make it yellow so it matches the style of the human IK controls. Maybe you can call it clavicle left. Duplicate it. Parent. Upper arm left. Line it here. And so on for the rest of the hierarchy. So really just mimicking the bone hierarchy. One thing we want to do every time though is freeze the transforms. Because if I look at the bones, the local rotation here says 0, even though technically there is an angle compared to the parent. See here? That angle, since we're in the bind pose currently, that angle is not stored here on the local rotation. It's stored in what we call the pre-rotations or frozen transforms if you come from Maya. So under degrees of freedom, rotation, pre-rotation, it's saved there. So this is the kind of baked angle delta between the lower arm here and its parent. That way, the local rotation that's like exposed to animators is zeroed out in bind pose, so that if you rotate like this and you animate and you want to go back to the bind pose, you can just zero everything on XYZ and come back to this particular delta. So we're going to apply the same treatment to our FK controls. Because here the FK control I created as the clavicle has a certain rotation. In fact, before I do anything, I want to parent this clavicle to the chest's FK control in yellow here, so that the wing hierarchy I create is part of the main FK human IK hierarchy. So spine 2 here. Why is it spine 2? Well, for the bone it was spine 3. It's because here the FK controls were created by human IK starting with just spine. So it's spine 1, 2. So it's like kind of base 0, 0, 1, 2. Whereas on our skeleton we use kind of the Unreal convention, spine 0, 1, 2, 3. So that's why 3 corresponds to controller 2. In case that's a little confusing. So here we are, clavicle is now parented to spine 2. So those FK controls will rotate with my chest. But if I look at this rotation, it's a weird rotation. So we're going to zero this out by just copying these values into degrees of freedom, rotation. And if it's grayed out, you have to enable it. Enable DOF, degrees of freedom. Pre-rotation. Okay. So I don't know why they stored pre-rotation under degrees of freedom. That doesn't mean you have to use degrees of freedom, which are limits if you prefer, if you want to clamp the possible rotations. So I'm just going to copy for X, Y, Z the same values that I see here. And of course that creates a weird offset because that delta is applied here in the local rotation and there in the pre-rotation. So it's applied twice. So we want to zero this out, and that will make our control go back to its original alignment. In this case, lined up with the bone that it mimics. So same thing here on the second bone. The values are different. Want to enable this, copy, 0 up, and this value. Make sure to put those values in pre-rotation, not post-rotation. Post-rotation will give you some strange results. Okay, and now it's lined up. So we keep doing this. So let me duplicate this, align it there, parent here, call it lower arm. And let's be careful because when I duplicate the upper arm here with pre-rotation, those pre-rotations got copied, and that's not good. So we want to get rid of that actually. Line up like this, and we can duplicate already for the hand. Line up there, parent it to lower arm. So keep in mind I hold X and I click and drag anywhere to do these relationships with the Maya shortcuts. Rename hand. Okay, so it's easier to just like leave the pre-rotation at 0, copy your, like make your entire hierarchy, line things up, and then work your pre-rotations. Because otherwise, every time you copy a bone that already has pre-rotations, you have to get rid of them before anything. So there's like extra steps. So here, let's continue this 2.98. So you're gonna have completely different values, I'm sure, depending on your rig. So this looks good. Just gonna do the same process for the other side, but I'm not gonna record it. It's gonna be the exact same steps. In fact, I might just duplicate what I have here, line it up, and fix the pre-rotations. So nothing new. So here we are. I have the two hierarchies for left and right wings. And every time there's the FK hierarchy, you can see the parent link to the last spine controller, as well as the bone hierarchy. So for now, they're not linked together. And very important, the FK hierarchy, FK controls, have the correct pre-rotation and local rotation set at 0. We can now prepare controllers for the IK. Same thing, I'm going to go to Asset Browser, Marker, gonna line it up with the hand to have it there. Just to follow the same kind of style as human IK, where the IKs are those red spheres, I'm gonna make this marker I created a red sphere as well. Going to marker settings, look, sphere. And in fact, actually, I'm going to make it a box, because that way, if I make it a box, I can make it fairly big like this, and I can make the hand, I'm going to select both hands, a little bigger than that, so it sticks out the box. So that way I can easily select either the IK box or the FK sphere, because they just stick out from one another. There's not one completely encapsulated in the other. Let me rename the box IK hand left. Could call it like wing IK hand left to make sure it's clear. And you can see in the human IK hierarchy, all the FKs are in an actual hierarchy with parenting, but all the IK effectors are flat. They're all siblings from one another, not parented to each other. So I'm going to do the same here. I'm going to parent my marker under the reference node that's created with human IK, so it's under that umbrella, but it's not a direct child of a particular object. This is going to allow us to make parent switching, space switching a little easier. So I can duplicate that object to make the hand right. Parent it and line it up with the other one. If you want, you may zero out the rotations like we did with the FK, so you may freeze transform them. One thing that isn't ideal with our hand IK controller here is that the translation values are very far from 0, because our object is parented to the reference object, which is at scene origin. So not easy for an animator to go back to this bind pose here if they want to, or to handle space switching systems for a rigger. So we're going to create an object that's going to be placed exactly on the same spot and parent our controller to that. That way it's going to zero out translation as well as rotations. So you can go to Asset Browser, and for this I like creating a null, once again just like the pull vector, because it's not an object that the animator is directly going to use or manipulate, so I prefer to use that rather than a marker. And I'm going to line it up to my IK control, make it a little bigger so it stands out like that, and gonna parent it to the same thing, reference, and we could call it group, as in parent group. If you come from Maya, you're pretty familiar to what a group is. Group wing IK hand left, for example. And now reparent your controller to the group. And translation is zeroed out, but the controller is still in the same spot. What's happening now though is we have some value on rotation because we have pre-rotation here. So the fact that we use this group parent object with no delta between the group parent and the controller itself means that we don't have to use pre-rotations anymore. So we can zero out those values we've entered previously and zero out the local rotation itself. And you should have your controller in the right spot, right orientation. For our IK, we're going to need a pull vector as well to drive the angle of the arm, kind of like this. So for that, the pull vector, I'm going to use a null rather than a marker. Just for convention, I prefer to use nulls for objects that the animator is not going to directly manipulate. And personally, I prefer not to animate the pull vector directly. I know a lot of animators are more familiar with like a pull vector as a separate object, kind of like far from the IK, and manipulating that in three-dimensional space, sometimes in world space or whatever. Personally, I don't really get it, because that means you have to manage 3 axes, X, Y, Z, and those are translation, to handle what to me is more a rotation. Obviously with human IK, you don't have to choose one or the other, you have both, because you can manipulate the elbow in translation, or you can manipulate the shoulder, the upper arm, in rotation. But a pull vector that's like far away, I really don't get it, because it doesn't correspond to anything in the anatomy, right? At least here, manipulating the elbow in translation, it's still, you're like directly manipulating the object that deforms the rig, but a pull vector is like an extra abstract object. And yeah, it's strange to me to animate that way. So I'm gonna make it more like this behavior, where you have an object here that you rotate on only one axis to handle the pull vector. But we still want the pull vector as an object. It's just going to be hidden at the end of the day. So let's create it as a null like this. I'm going to call it wing IK PV as pull vector left, for example. So let's line it up with the upper arm and slide it kind of like that, and slide it like that. Make it pretty far. What I'm going to do is create the right one at the same time. So right, like this. Yeah, I'm going to temporarily parent those to the upper arms. Parent. So their respective upper arm. It's just so I can, translate them like this in local space and slide them down, up, and I get some values that I can like round and then mirror for the other one. Okay, so you see there's the left wing here moved correctly, but the right wing kind of went in the wrong direction. So I'm just going to do minus here and minus there. Or if it was already minus, I would have converted it to positive. So just multiply the result by -1. That way, they're just perfect mirrors, right? If I go to side view, they are lined up, so they are mirrored correctly. But we're not going to let these pull vector null objects parent it to the upper arm. We're going to parent it to another controller. So let's create that controller. So marker, because something the animator is going to manipulate, and we want to be able to change the look of the marker, which a null won't let you. Null settings, you can either set it to none or cross, but a marker, you have all these options. So let's line it up to the upper arm. Align. Let's scale it up and change it to circle, for example. And I would like that circle to be kind of rotated like this, but I don't want to rotate the actual object, because that affects the rotations I see here. I just want to rotate the geometry of the circle without rotating the gizmo like I'm doing here, the pivot. So going to transformation pivots, geometry offset, so 90 degrees. Oh, no, sorry, not translation, rotation. 90 degrees, boom. Now the circle is, you know, kind of makes more sense with the direction of the arm. I can scale it up again, just so it sticks out of the geometry. Okay. And I'm gonna leave it red, so it's the IK color convention. So wing, IK, I can call it twist, left, duplicate that, line up with the other one. There we go. So for now, I'm just gonna parent these under the same reference umbrella. But we'll see, we'll do some extra things here. We'll add some nulls so we can space switch those objects to make them follow you know, the chest or just be in world space, that kind of stuff. For now, let's go into constraints and create our IK constraints. So chain IK. Okay, and we can directly bind the FK hierarchy to be driven by our IK controllers. I'm just going to hide the bones here, so I'm not tempted to select the green bones, although, wait. So this doesn't seem to affect those bones because those bones, they're not part of the human IK characterization. That's fine. I'm just going to go to the skeleton view, select all those bones, and just hide them like this. So chain IK. First joint will be our upper arm, not our clavicle. And it's possible in your rig you don't have a clavicle if you don't want to, that's fine. So first joint, upper arm, and joint the hand, so I can select it here easily. I can also press the down arrow twice to go down in the hierarchy. Effector will be the IK hand. And pull vector object, we can select our null. And you can press snap. My pull vector is still parented to the upper arm, so I will parent those to the twists. Forgot to do that. Okay, normally nothing happened, but now I can move them like this, and it will rotate the FK. You may see that when I rotate like that, I mean the geo is not bound to these controls just yet because the bones are not constrained to the controllers just yet, but you see the sphere is rotating, and we won't want that. We'll want the hand to be constrained to the IK in this scenario. So I'm going to add another constraint, orientation or rotation, this constraint to that. So always snap and lock. In this case I could have done a 0 as well, but snap is maintain offset. In this case I don't have any offset, so if I select the rotation and go to rotation settings, rotation is 0, 0, 0 because I lined up the IK to the FK hand in the first place. So if I rotate this, it inherits the rotation from the IK control. If I rotate the pull vector, the arm swings or swivels, but the hand stays in the orientation of the IK control. So the idea is that instead of manipulating this with translation, like I said before, because it's just strange to manipulate what is a rotation with XYZ translation, for me it just doesn't make sense. Except if you have to lock the elbow against the floor or something like that, but that's a very rare case. So here, because we parented our pull vector to our twist control, little circles, you can just manipulate the circle like this and get the same result. So you just have to worry about one axis, which is much more comfortable when animating. The only thing that might be a little strange at the moment is that our controller can be animated on the two other axes as well, which is not ideal. So we're going to lock them so we can only animate on X, which is the most relevant axis here because it's the twist axis of the upper arm. So there are several ways in the properties to prevent the object from rotating on Y and Z and just let it rotate on X. But first we need to fix an issue with the rotations. You'll see our goal is to limit the rotation on the X-axis like that, but the thing is right now those rotations are not relative to this particular base orientation that our object has, just like the FK arm. It's based on its parent, which currently is the reference joint. So it's well-spaced kind of rotations. So if I rotate the object just on Y, for example, you'll see the rotation goes in a weird direction like this. Okay, it's not like a rotation around this axis, for example. And if I do on Z, it's like that as well. So it's weird. It's just kind of relative to the scene, if you will. It's kind of these orientations like that, right? I just pressed F6, switch to global there. So it's kind of this rotation. You see, it's not lined up with our circle. So the thing we need to do is just create a parent object, just like the IK hands there. So actually, let me just duplicate that and call it group win twist, for example. So it's a parent group. I'm gonna line it up with the current placement of the IK twist, aka our forearm, you know, just this alignment. So it's right there. I'm gonna press F5 to go to local mode again. So we see the orientation matches the twist itself correctly. I'm gonna parent this to reference just to keep it organized, and I'm gonna reparent my twist left to this parent group. So now by default translation and rotation are all zeroed out because our twist control circle thingy is a child of an object that's placed exactly in the same spot, so there's no delta between that object and its parent at the moment. So the parent has all these weird offsets from the world origin, the scene origin right there, but the controller itself is zeroed out without even using the pre-rotation. So exactly what we did for this one. Now I'm going to be able to work on those rotations because if I do this, it's only on X. If I do that, it's only on Y, and that only on Z. So this is all correct now. So two ways. You see the pre-rotation we've worked on before are under something called degrees of freedom. So degrees of freedom sounds like something that could work for us, because if you limit the degrees of freedom, you're limiting how much the object can potentially rotate. So you could do enable rotation DOF and go under min and max here. And you could say, I want to enable min and max on Y and Z. But you'll see there's some limit to that method. And leave X alone because we still want to be able to rotate on X. Just want to limit it on Y and Z. So just check those boxes. And we leave the values here, X, Y, Z, X, Y, Z. We leave it at 0 for all of those. That way it's like you're not allowed to go below 0 or above below 0. You're just locked on those axes. You see now I can't manipulate Y at all, and I can't manipulate Z at all. But when rotating the axis a little bit like that, you see what happens on the local rotation there. There's still some number getting added there. And like despite, you know, my gizmo rotating and then snapping back to where it was, because it's limiting it, it's kind of limiting it after the fact. There's still this input in the local rotation itself, and that's kind of dirty. We don't really want to work with something like that. It can only be messy because, you know, if I'm if I disable the degrees of freedom limits, you could think of those as limits. Now my object is rotated because it kept that rotation that got added when I manipulated. So it's not great in terms of user interface and rigging like values, you know. So if I zero this out, we're not going to use these. We're going to use a better method, which is just locking the channel. So, you know, very often we lock entire properties, but you can actually just lock one channel of a vector property in this case. So if you right click specifically on Y, you can lock just that channel instead of locking the entire thing like that, you know. So just lock this channel and then lock Z. And the advantage, I don't know if you saw on the viewport, I can unlock Y so you see again. You have those dotted lines when at least one axis is locked, and if you lock two, they become grayed out. And in terms of user interface, that's better because it's going to tell directly the animator you can only rotate here, because only this is meaningful, because it's an IK twist, right? So only this is meaningful. So this is the good method to do this. And then one other thing that's very important is the planarity of the limb. So I will explain. So if I move my IK hand like this way, for example, all the way to the left of the screen, you see the twist didn't follow along, right? The twist just stayed oriented in its original direction like that. And the problem with that is that now if I rotate on X, it's kind of rotating in a weird direction from the IK. I don't know if you know what I mean, but now the direction of the limb is like so, more or less, drawing with my mouse here. But the controller is this way, right? So when I rotate on X, like this, you know, along this axis, like that, and my ball vector it's not going to rotate along, like kind of around this axis like that. It's rotating more around this axis like that. So it's like there's one direction this way, like I drew first, and there's another direction that way, and we're not twisting around the direction from shoulder to hand. We're twisting around just the original direction, but in this case it becomes kind of arbitrary and biased, or you know, it's like kind of sideways from the limb, and that's not the best. So what we want is the twist to kind of like always look at the hand, right? By default. So if you think of an IK like a two-limb IK like this, it's like a plane. That's why sometimes you'll hear riggers talking about planar limbs. It's a plane in the sense that it's a triangle, so it's 3 points. Here are the shoulder, the elbow, and the hand. And you might remember from your math classes, 3 points create a plane. So that's why in the geometry, for example, for meshes are triangles. They're quads, but more importantly, they're a quad is two triangle because like when you have a quad, the fourth vertex is not necessarily on the same plane, because you could have like the triangle like this, kind of flat, and the other point like not on that plane. But if you have a triangle, it's always a plane. So here we have this plane here. So kind of drawing the line here and that one. So that's kind of a triangle. And usually like for normal human articulations, like hinge articulations like that one, or on knees for legs, when you rotate, you want kind of the wrist to get closer to the shoulder, right? Like that, like not rotate. If I disable my AK, you know, it's not going to rotate like far like this to the side. It's going to rotate toward the elbow to bend, right? And so when you create IKs in Maya, for example, it often like shows you a line here. That dotted line kind of shows you the link between the first joint and the end joint. So thinking of that plane here, which I could like fill up like that, and thinking of that dotted line, the twist really, the rotation of our twist control, we want it to always be around that dotted line, which we lose if I again put my my K all the way over there and I rotate, you know, this way. The red line is now false because we have a new dotted line going this way, right? So we're just simply going to use an aim constraint to create that behavior, but not directly on the twist because we still want it to be able to rotate. So we're simply going to do it on the group parent. That's what it's for. It's to do some pre-manipulations on top of what the animator can control. So let's create an aim constraint. Okay. The constraint object will be the twist parent group. The aim_at object will be the hand, IK. And for the world_up object, that one isn't always the most intuitive to understand, but we kind of want an object that's gonna rotate with the whole character and actually rotate with kind of the twist. So later in the video we'll make something so that when we rotate the clavicle, the twist follows the tip here, like basically it should follow in position where the shoulder is. And basically the clavicle here is the start of our wing, and we kind of want it to be the referential for our lookat, meaning like if I rotate like this, then the up point is still like kind of relative to the clavicle. We don't want it to be relative to the scene, because if you have your character, I don't know, rotated all the way like that, then the upside would be like seen up instead of being like relative to the clavicle, and that would give you some issues. So there might be a bit of trial and error on your side to figure that one out, but I'm gonna go ahead and use the clavicle here, because it's kind of, again, the, so to speak, parent. It's not literally the parent, but kind of the anchor point of our twist control in the first place. So I'm going to use that. And then before activating it, we need to tune some settings. So go to aim settings here. So we set up the constraint objects, aim_at object, and world_up object. Now, what is the aim vector? So if you select the locator here, the aim vector is the one that mostly points towards the object. I mean, technically here, our locator x-axis, for example, is pointing at the elbow, not at the hand. But generally speaking, it's kind of this main direction, right? It's still the x-axis that's the most toward our object over there. It's not y and it's not z. So we're gonna pick x here, and I'm gonna lock the properties so I can stay on that view. So this is x, y, z, and you can see here the entire weight is on x, because those are normalized values, so it's between 0 and 1, okay, or -1. So between -1 and 1 to be precise. So that's it. We can leave it like that. The up vector, in the case of this aim, the most relevant here will be y-axis, because it's kind of this one going down. So for me, I found that that's the most relevant. But if you feel like z makes more sense, you would do this. You would zero out the value on y, and you would do z, like that. Yeah, one thing actually is that here y is toward the floor, so if I want, I can say actually my up vector is -y, so more like this axis over there, going up. So I can do -1 like that. Okay. Rotation offset, we're going to leave that like this, and world up tight, so instead of being seen up, I mean, we specified a weld up object, but we need to tell it to actually use it. So here, instead of scene up, you could choose object up or object rotation up. What is the difference? If you do object up, it means you're specifying an object that's like placed, like kind of, for example, up there. If you think of my negative y-axis, so if I say object up, I'm saying you need to keep your up axis pointed toward where that object is placed. So you're gonna keep X towards the IK handle, you know, all the way out there, but you're gonna keep your negative y-axis pointing toward that object. In this case, I don't want to create an outdoor object and kind of place it arbitrarily in a strange spot like that. I prefer to say just use the direction of an object. So I'm saying use the direction of the clavicle. Use the orientation of the clavicle as your reference. And in this case, better to use a direction because a direction is infinite as well. Whereas an object could be, you could be beyond that object. It's a little getting a little philosophical here, but yeah, I just find it way more reliable to use object rotation up. So we're using the rotation as an object as our reference. And in this case, just going to use -y. I'm going to keep it consistent with my up vector because those two objects are roughly in a similar orientation. So I'm just going to do it like that, just keeping the same value for both. But you know, if this object was, I don't know, X pointed up like that, you know, if I did some weird rotation convention when lining up my FK controls and my bones, then I would probably select 1, saying like I want my 1 vector to be like to correspond to my negative y vector like this. So you need to look at your objects like that in local space, local gizmo mode, I mean, and translation mode, and understand how your objects are oriented and how they want to follow each other, and tune those vector values based on that. Once you've done that, you've set up your settings, you can go ahead and snap and then lock. Actually, you can see that when we snapped, the rotation offset got filled up automatically, because on the very start, like when I activated things, the again, this object here points there. Like I said, it doesn't point exactly towards where we want it to point. So this is kind of a maintain offset. So this value here is like a maintain offset. It means it maintained the delta between the actual direction and where we're oriented. That way my object by default is still oriented this way. So now if I move the IK hand somewhere to the side, my twist control is still oriented towards there. In a way, we're rotating along kind of the perpendicular plane to the arm plane, if you will. So you have the arm plane like that, and we are orienting our control on a plane that's like more on this side, you know, like my red circle here and the red gizmo. So it's like two planes that are perpendicular with each other, and that's much cleaner to handle the rotation this way. And it's actually going to make things easier to set up the IKFK switch down the road. So out of curiosity, if I select the chest and rotate it, you can see the behavior starts happening on our controllers, where on the right side here, I'm talking always in character space. So screen space it's left, but character space it's on the right side. The IK controls don't influence the FK controls yet, so the FK controls are just in local space, rotating along with the chest. but the IK controls on the left side of the character are kind of parented to nothing, right? Our group objects are just in world space, so they kind of stick around like this, and our wing follows along. So immediately you're gonna think, okay, that's not ideal. I don't want those controls to necessarily stay in world space like this. I mean, if those are like legs that should be grounded, then sure. But in this case, for wings, we're probably gonna want them to kind of follow the chest, at least with some position constraints. So here, for example, with the clavicle, if I rotate the clavicle like this, the twist control should follow in position with an offset. So basically, the twist parent group should be parent constraint to the clavicle. So let's make a parent constraint where clavicle is going to drive, and the twist parent group null object is going to be driven. So I messed up here. That's fine. I can fix it by dragging the clavicle as a second parent and then dragging back the group in the constraint object field. I can snap and lock. Okay, and now if I rotate like this, it follows with it. Therefore, if I rotate the spine, the twist bone follows along. And because that parent constraint influences both translation and rotation, when I rotate the chest, the elbow also kind of rotates because the pull vector rotates, because the twist rotates. So we can just go to the parent-child, properties, and constraint axis, and we can deactivate the rotation axis if we want. As a result, when I rotate the clavicle, the object orbits around the clavicle, so it stays at the correct distance from the clavicle, like a radius, but it keeps its own rotation. See, when I rotate like this object keeps its own rotation. So it's a little different than if I had done a position constraint, okay? A parent-child constraint with only translation axis activated is different than a position constraint. Just to reiterate, with that setup, when this object rotates, the point here that is at this distance, so kind of the clavicle distance, is going to orbit around the clavicle and maintaining that distance. Okay, like the Earth rotating around the Sun. Let me go ahead and rename a bit of those constraints so we don't get lost. So parent twist to clavicle left. The rotation here was the rotation hand FK constraint to IK. So this is my naming convention. Object A constraint to object B. And here chain IK, so you could just call it IK left. We're going to put everything in a wing folder at the end. And the aim constraint, I'm going to name something like aim underscore twist to hand left. So it's an aim constraint where the twist is looking at the hand. So we're basically going to do the same parent constraint for the IK object. I can duplicate that constraint, name it parent IK to clavicle left, deactivate it, select not the IK hand controller object directly, but its group parent, and replace it there as the constraint object, snap and lock. And go into properties, And well, the rotation properties are already deactivated because I duplicated the one we did before. If you made it from scratch, make sure to deactivate that, and you should get this behavior. Let's see, is it the behavior we want? It's not exactly the behavior I want, because I would like when I rotate like this, see here how my wing is oriented like this way. I would like to preserve that orientation so that when I rotate like this, the wing moved along. So from this pivot here, because remember the clavicle rotates, so the twist object rotates around it, but I want the wing to kind of keep that original direction. So it's easier to animate the wing smoothly without inheriting all the micro, rotation that might come from the spine or the clavicle. So I did something wrong here. And I think it's just the fact that our object being constrained to the clavicle, it orbits around that point over there. And so when I rotate like this, the chest or the clavicle, I can rotate just the clavicle, it orbits all the way around there. So it still has its own rotation. Okay, if I go back like, if I rotate this back to 0, you see here how the hand object is oriented this way. Let me draw to remember. It's kind of oriented like that. And so if I rotate the clavicle, poof, and I select the object again, it's still oriented that way. It's parallel. But it orbited around, so it gives kind of this new direction to the wing, which I do not want. So in this case, it actually makes sense to use a position constraint. Insert constraint position. I'm gonna just grab this name bit position. Let's see. I don't think I'm gonna position constrain it to the clavicle. What I want is, if I rotate this object, I basically want the IK here kind of like maintain that relative position from the twist, from the shoulder. So that if I rotate the clavicle like this, the shoulder ends up here, and we want to keep that parallel direction. So I'm going to use a position constraint where the IK parent group will be constrained to the twist parent group. Twist. Let's delete that one. Position. So DIK parent null. I just pressed the up arrow to select the parent. Up arrow and directly select it. It's just a little tiny on screen. So source object. No, sorry. Constraint object. And the source object will be the twist parent group. Snap and lock. Snap to maintain that offset. And now if I rotate, yes, that's the behavior I wanted. Okay, that's nice. If I rotate the spine, same thing. So the wing is going to be much more stable, and so I'll be able to, animate the torso, animate the clavicle kind of doing some efforts here, and then it's going to be very easy to kind of animate the wings doing this motion here and like having the hand do this. But again, if you want to set it up differently, it's just a matter of how you handle the parent or position or rotation constraint, but always apply those constraints to the parent groups so that you can animate the control on top of that group, right? The groups are just here to determine the spacing, or like the, in relative to what is the object gonna animate. So just let me go ahead and duplicate this stuff. to set up the right wing, now that we're kind of fine with the left wing setup, at least the IK part. Alright, so I duplicated everything, renamed the constraints, and changed the objects by first deactivating the constraint and then reactivating it with snap to refresh the maintain offset values. So I'll duplicate the aim constraint as well to have it on the right side. So if we look at the settings, well, first deactivate, unlock, change the objects obviously. So the twist right, looking at the right hand, and the space of clavicle right, and just check your axis orientations. So when I do local translation like this, you can see that now it's pointing towards the object in negative Z. There's no arrow there instead of positive Z. So I'm going to set that to -1. And now it's the Y up axis like that instead of Y looking down. So I'm going to change this value here from -1 to 1, both for the object itself, the up vector of the object, and the up vector of the reference object. So for clavicle right, it's also positive Y this time around. Okay, now I can snap and lock. Like previously, it's going to refresh the rotation offset and make sure it cannot be changed. And they should give me the same thing. You know, the twist keeps looking at the hand. And I should have the same behavior on both sides. The IKs remain stable in terms of rotation, but they do orbit around the clavicle by keeping this initial translation offset, so the length of the clavicle. If you do not have a clavicle in your rig, you do the exact same thing, but use the spine controller as the parent for this particular constraint, where the wing twist parent group is parent constraint to here the clavicle if you do not have one, the spine last FK control here. So parent constraint with remember rotation XYZ deactivated. So now we are always in IK mode, and we're going to make a relation constraint to be able to switch between IK and FK. So relation, call it IK FK switch, and we're going to use it to drive some of these constraints automatically. Which constraints are going to be activated and deactivated? Definitely the IK left one. So make sure there's this little A property lightened up. Okay. That way, when you go into relation IK-FK switch, you can drag and drop your constraint, and you can choose whether you want it to be a sender or receiver. In this case, we want it to be a receiver. It's going to be driven. So you see that weight property based on the fact that it's animatable. If I try again with another constraint which is not yet animatable, if I try to drag and drop this rotation thing here, I just see this node with no input and no output, so it's unusable. But let's see, which one do we need? Rotation hand FK to IK. So the fact that our FK hand is rotation constraint to the IK, definitely something we want to disable when in FK mode. So let's make that animatable. I'm going to do that for the right side at the same time. This one, aim twist to hand left. So the fact that our twist control parent group is oriented in aim constraint towards the IK. that's something that should always be on, so we don't have to make it animatable, I think. The parent twist to clavicle, so the fact that the twist control is parent constraint to the clavicle, and remember that's the one that's just in translation, so that keeps that object position on the upper arm. That's also something that should always be there. There's no reason to like deactivate that and have this object go far away from the upper arm. So not something that needs to be animated. And this one, the fact that the IK parent group stays at a regular offset from the wing, that's also something I think should stay on because it's kind of the core setup of the IK stuff. It's not a constraint that make the IK objects drive the FK object. It's just something that sets up our RK control, so it should stay on. So we're just going to deal with the first two constraints for each side. So animatable, animatable, and now we can drag and drop them in here as receivers always. I'm going to put the right side constraints together and the left side constraints together. Okay, now we're going to need a property to drive those. And for that, I'm going to make a custom property on each IK hand control. So properties, editor, custom properties, and I'm going to add a bool and call it IK mode. Going to do that on the right side as well. Custom properties. Might have to leave and come back. But here I created the bool. I can rename custom property, call it IK mode. Okay, so they appear now at the bottom. And again, want to make them animatable. And I can drag and drop these as senders. And use this IK mode to drive those constraints. Now the IK mode is a boolean, so it's either 0 or 1. So we want to multiply it by 100 to be compatible with weights, because weights are percentage. So number multiplier multiply by 100. Just do this. Alright, and we can right click here and do hide unconnected if you want something more compact. Now these IK modes, you could either like turn them on manually, but personally I like just driving everything from the master relation. So I just have to click it once and it's active on all the takes in the scene. So I'm gonna grab these two again and set them as receivers this time. So as an animator I can just go in here, expose this, like with right click set value and toggle it. And when I toggle this in the relation IKFK switch, this became 1, on the other side it's 0, because right now this is unchecked. So 1 versus 0, multiply by 100, it's 100, but here it's still 0. So basically those two constraints are now active. I mean they're always active, but their weight is also at 100%. So on this side my AK is driving, and on the other side it's not doing anything. But there's still, you know, the behavior of like the aim at, for example, where this is aiming towards there. So if I were to activate the IK now, it would behave correctly automatically. So now we need something that when the IK mode is deactivated, like here on the right wing, the FK should drive the IK controls. So for the IK handles, it's going to be fairly easy. It's going to be simple parent-child constraint. So this object follows wherever the IK hand, so the tip is. So parent constraint, parent IK hand, or to follow this convention, I could say parent hand IK to FK left. So this is going to be driven, and this guy here, the FK hand, is going to drive. Let's duplicate, rename, do the opposite. Right side. And now we can select both constraints and zero out. We want no offset, so we can just zero it out, meaning we're activating it with zero offset. And it's automatically locked. And we're going to make it animatable, and we want to make those weights automatically driven by the IK-FK switch. So like before, drag here, receiver, drag and drop, receiver. But this time we don't want it to be at 100% when the boolean is at 1. We want it to be reversed, because this is a constraint that should be active when we're in FK mode, so when IK mode is off. So I can just use the number node if condition then A else B. So this is actually a node we could have used instead of the multiply in the first place. We could have said if true, so if this is equal 1, make this output number be 100, and if false, let it be 0. So that in this case is the equivalent of the multiply, but for our FK constraint thingy, we want it to be reversed. So when this is true, we want to output 0, and when it's false, when we're not in IK mode, we want 100% of that constraint being active. So we can duplicate that node, plug it there, boom. Okay, so on the master relation, the IK mode is on for the hand left, and it's the same behavior as usual. But on the right side, it's deactivated. So if I rotate the FK, you can see now the IK handle follows in translation and rotation. Now, a little more complex. We need something to constrain the twist controller to the FK. Because here in FK mode, when I rotate like that, I rotate the entire limb, and it's pretty good because since we left our aim constraint active, meaning the you can see here the twist control keeps looking at the hand, we have a good base here. But if I rotate like this, you can see my pole vector is kind of going in strange places. Like here, when I'm rotated like that, I don't know if you see, but my plane is like this, right? I have a plane here pointing kind of downward that way over there. Let me hide the mesh so it's easier to see. So I have a group with the geometry. Okay, but the pole vector here is down there. So if I had achieved this pose in IK mode, my pole vector would be on that same plane, right? So it would be somewhere over there. You know, the elbow would be pointing at that pole vector, meaning my twist control would be rotated a certain way on X like that. But currently it's not the case. I mean, my twist control is constrained on Y and Z to look at this object, but it's not constrained on X to kind of like keep the pull vector pointing down in the direction of the elbow. So it ends up in weird places, and if we were to switch back from FK to IK, we would have some strange pops. Like if I were to activate IK now, I wouldn't preserve this particular pose with the elbow towards the left of the screen here. I would end up with the elbow popping like kind of on this plane to line up with the pull vector down there. So not good. So basically we want to make it so when I do this kind of rotation, the elbow orbits around instead of staying where it is now, you know. For that, we're going to use something quite powerful. We're going to use a 3-point constraint. It's kind of going to behave like the opposite of an IK twist system. It's you'll see it's pretty nice. So 3-point, we can call it just 3P for short, and it's going to be the twist control being constrained to the FK structure. So we're working on the right side this time around. So the constraint object will be our wing IK control this time. We're actually leaving the aim constraint that handles the twist parent group on. Okay, we're not touching that. So this is kind of on top on the controller itself. So constraint object is the twist controller. The origin will be the upper arm. The target will be the FK hand. And the up will be the elbow. Just snap and lock. And now pay attention to how the pull vector behaves, because that's kind of our indicator of how the twist is oriented, right? With you know, the y-axis being like this by default, and the z-axis being like that. The pull vector is kind of a projection of that, right? So if I rotate the elbow like this, close the elbow, remember how my mesh is. It's like that. So this would like bend the arm, just like here, you know, the equivalent of this, just a natural hinge rotation. My twist pull vector follows. And if I do this twist, you see the difference with what we had before. It actually rotates along, so the plane is maintained. Okay, like that. So this is pretty nice. And the additional value of using the 3-point constraint is that if I decide to break the elbow, so instead of rotating here in the anatomically comfortable direction, if I can call it that way, the elbow bending direction, what if I break it? What if I rotate it this way? Okay, it's on the arm, it would be the equivalent of rotating like this on Y. Okay, so I would break the elbow like this, right? Which sometimes, you know, you animate very quickly. Instead of limiting yourself to like just bending this axis, meaning that if you want the elbow to go like kind of on the side like this, I mean not the elbow, but if you want the hand to be someplace there, you know, traditionally you would like rotate it like this first on the upper arm and then bend on the z-axis here correctly. But with MotionBuilder you can be a little more intuitive than that. You can just break it the way you want. So yes, you break the articulation because it's not just articulated on the z-axis here. So I have some values on y, but I've showed in another video how to fix this. Once you finish your animation and you bake, meaning you put a key on every frame. Here I'm just going to do it manually on key number 2 where I broke the pose. You would activate the IK blend, translation, and rotation on the hand, and the IK blend, translation on the elbow. Then you go in your F curve editor. You want to do it on the FK control. So X and Y, zero it out, and look here. Boom. My elbow is fixed in terms of internal rotation, but the positioning of the elbow here, this particular position, it's still maintained in space. We're just fixed the rotation. I mean, I could break it again by selecting the FK control again, rotating on Y. You see, it's twisting the elbow. It's like doing this. You know, it's incorrect. So with human IK, it's pretty easy to fix that out of the box, like I just showed you. And here, with our 3-point constraint, we are actually doing something similar on our IK system. So that if I break here like this, you see the pull vector, what it's doing is it's orbiting around and it's putting itself over there. So that now it understood that the plane, instead of being along, you know, this axis here, you see the plane here on the z-axis, it's flat. I have a plane here. So if I break it like that, it understands that the plane is now like this, if you will. So it lines up itself to stay on the plane that that triangle defines. Which means that once I switch to IK again, it'll understand that despite the fact that I broke the elbow, now it's going to understand to actually fix that rotation in the elbow by rotating the upper arm and preserve the correct bending of the elbow. I think to demonstrate that, I need to wrap up the system by fixing the IK FK switch automatization. Then we need to add the controllers to character extension, and then I need to bind the bones to the controllers so you really see live what it's doing. So let's make this 3-point constraint animatable. In the IK-FK switch, let's set it as a receiver next to the one we did before. So that one should be active when we're in FK mode. Let me do the equivalent for the left side. Let's replace the objects. Okay, so I have the left side, it's going to be driven like that. Right side, that's good. Now what I want to do is add all my controllers to character extensions. So you can open up characters, right click on player and do create character extension, or you can go on character extensions, right click insert character extension. I prefer to do the former because that way when I create it on display extension, it's already attached to the correct character. If you do it with the second method, the attached character field is empty by default, so it's not the best. It just creates an extra step. So I like renaming those a certain way, and I can call that wing left. Let me create a second one, wing right. I'm gonna add both the IK controls and the FK controls of one side into one character extension. Same for the other. So right and right. I've left these markers all red the entire time, and I know it's confusing with the nulls that are also red, so I think it's overdue to change the color of these to some kind of, I don't know, orange, for example. But let's see, I think I just put the wrong objects in there. IK hand, so that's a controller. That's a controller here. Oh yeah, I put the pole vector, and I don't want that. I'll detach this one. Make sure to put in the twist control in there. Okay. So when we add objects to a character extension, they become a little semi-transparent like this. So this proves that they're part of your character. Okay. One thing you might want to do is add something as a reference object. So when you store poses and you apply poses, they're going to be applied relative to that object. In my case, I think it would make sense to do it relative to the spine bone. And for these, it's good to select a bone, not a controller. So for both, actually, it's going to be, I can select both. It's going to be spine 03 in this case. Reference object, drag. There you go. So let's bind the bones to the controllers. For that, I already have a import relation, and inside don't touch and driven constraints, I have these two constraints where the bones are constrained to the controllers, or the controllers are constrained to the bones. So these two constraints are driven, so their weights are driven by the import relation. So based on my root controller's import mode, which is just a Boolean property, import mode. When the import mode is true, it activates the constraints where the controllers are constrained to the bones, because we want to bake the data coming in from an imported FBX, motion file import. We want to bake that data onto the controllers that are all our custom controls, are not part of HIK. And when import mode is deactivated, it's to animate, therefore the bones are constrained to the controllers. So in bone to controls, I'm gonna add the wing bones as receivers. So in this case, I'm just gonna care about these clavicle, upper arm, lower arm, hand, not the twists. Receivers. Same for the other side. And in the other constraint, they're going to be senders. Okay. They're going to drive the FK controls when import mode is active. So selecting the same order, that way they're all lined up. I selected clavicle first, then upper arm, then lower arm, then hand. Did the same for the control. This way they're all face to face. Because if I do clavicle, lower arm, upper arm, hand, it's messed up now. Those two are flipped. So you save yourself some time if selecting properly. So now I'm gonna link all this. If you don't plan on animating the scaling, you just leave the scaling unconnected. If you don't plan on animating the scale, you can leave the scaling disconnected. Okay, and the opposite in the other constraint. Okay, so you might have noticed I haven't constrained the IK controls. So what's going to happen to them when we're in import mode and the bones are driving the controls? Since we already have a setup, the FK mode, that makes the IK controls follow the FK controls, what we can do is add just another rule that's like here in relation IK FK switch, we could say IK mode or import mode active. You know, we can inject the import mode into this logic here to say that if we're in import mode, we want to force the IK mode to be false, and that means we want the FK mode to be true, meaning the FK controls will drive the IK controls. It's just that the FK controls will actually be driven by the bones. So here I'm going to grab my root bone and add it as a sender. That gives me the import mode here, which I care about. So let's see, I want IK mode to be true if it's true in the first place, and if IK mode is false. So boolean not. So if the import mode is not true, and I can already right click hide unconnected. So for each limb, for their own IK mode to be considered true, we also need import mode to be false. So I'm going to add an AND here. For both. And so import mode here, sorry, the not. Okay, and the import mode itself for each. So you see I have import mode not plugged into one of the A or B thing, and the other one there. Okay, and that becomes my new condition. So instead of this being always true, it's going to be the result of this thing with an extra condition. So I can plug and disconnect, so there's only one. So plug and disconnect. Okay. So in this case, on my master relation, IK mode is true on the left side. So currently in the relation IKFK switch, it is true, and the output is true because my import mode is false. So import mode is at 0, meaning this is at 1 after the not. So these two conditions are true, therefore the result is true. So IK mode is totally effective here. On the other side, on the right side, well, master relation says no IK mode, so it's in FK. Now, if on top of that I activate the import mode here, now, despite the IK mode still being true on the hand left side, in IKFK switch, the import mode is now true, so it's not true. You know, it's not false. This is 0, and so those two conditions are not met. Therefore, the result is at 0. So you see now my bones. Selecting the bones here. My bones drive the show, and therefore they drive the FK controls of the wings. Okay, I can't rotate the FK controls of the wings, and the FK controls of the wings do drive the IK controls. So I hit 2 birds in 1 stone here. Yeah, by just saying the FK should drive the IKs when we're in import mode, because in import mode it's FK data anyway. It's just that FK data comes from the skeleton itself. I hope this makes sense. Just gonna put everything back to animation mode. So now that the whole setup is working, we have character extensions that contain both the FK controls and the IK controls. I can activate the IK modes. So if throughout my timeline I pose the IK controls a certain way, in body part or full body mode, so let's say like this particular pose, I move my IK handle, I rotate it, and I rotate my twist like that. You can see now the effect that it has. Okay, you can see the hand has its own rotation. This has its own twist like that. So I do this, and then I'm gonna key in body part. So let's put our IK FK switch to the test. I'm going to deactivate IK mode and the pose should remain the same. Yes, it remains the same. The only thing is here we have a little adjustment on the IK twist because it's like our conversion between IK and 3-point constraint. And now normally if I key again and go back to IK mode here, there's a little back and forth. That's not as seamless as it should be. So yeah, there are some precisions in setup currently, which you don't see if you stay in bind pose, because there are all the offsets are perfectly lined up between IK and FK. But if you start putting the IK in a certain pose, like this, and twisting around, so let's say you do that on a certain frame, this in your key in body part. When you're going to go to FK mode, there's going to be a little twitch like that, you know, like this. And because of that, when you key your body part again and you try to go back to IK one more time, there's going to be a little pop because of the little pop that seemed harmless before, but when you go back to IK, it actually changed the pose like a little too much, because you see it changes the position of the elbow, which is not ideal. So I just realized that actually the fact that we made the aim constraint point at the elbow like this is not the best. So basically the offset here we have rotation offset is not the best. So what you can do to fix it at that point is activating the IK mode, but deactivating the IK constraints, deactivating the twist constraints and unlocking them. And then inside the properties, now rotation offset is not grayed out anymore, you can zero that out. And now if I reactivate this constraint here, I will select the locator to show you what happens. Instead of having the locator point at the elbow, it's actually going to point at the hand for reals. Now it's really pointing towards that dotted line I mentioned before, the invisible line that links the upper arm and the IK handle. So that's going to make the relationship, the conversion between IK/aim constraint with FK/3-point constraint a little more seamless, a little more precise. So after reorienting your aim constraint to be facing at the real hand point, you want to update your 3-point constraints as well. So while being in IK mode, you want to deactivate your 3-point constraints like so, unlock them as well, and you can snap them again, so they will understand the new angular delta now. So you can do one by one with snap and lock, or you can do multiple with snap all and lock all. And now if I do the same exercise as before with this pose here, I'm in IK, can twist around, key in body part or full body, or bake the entire timeline if you're animating, and deactivate the IK mode. See, it's practically seamless. There's a little bit of twist that gets introduced here, just like little difference between the way the IK solves versus the 3-point constraint. So it's a little difference between our aim constraint and our 3-point constraint. When I do that, I key again while in FK, and if I go back to IK mode, it's practically seamless. Maybe I have some errors in my own rig that you don't. And the really cool thing I wanted to show here, if you're an FK, so just similar to what we did before, we broke the elbow like that, and then we fixed it with the IK blend translation, and fixing the value on Y and X. You can do the same thing with this setup. So I'm in FK and I just animate freely, not really thinking like in terms of rotation, am I respecting the anatomy? I just think about the shape, the silhouette, and where my hand is placed with that rotation. So I might just break the elbow a little bit like that. So now the planes are broken, right? The biceps, if you will, is kind of looking this way while the forearm is looking that way, so the plane is broken. In FK, that's totally possible to do. But if I key to break that pose and I go back to IK mode, look what's going to happen here. Boom, it fixed itself now. The upper arm is now doing all the rotation necessary to fix that elbow and keep the elbow in place at the same time. So now the biceps is kind of oriented that way, and the forearm is oriented that way as well, so they face each other, and the planarity of the limb is maintained. And so I'm not sure a lot of IKFK switching systems allow you to do it. So for me, that was a very important feature because it's something that exists in the human IK out of the box. Of course, that rotation that's now added to the upper arm, so that will add a bit of candy wrapping here if you have a skin model. In this case, I have kind of this gray box, but of course you would have twist bones that would counter that rotation, just like you have on upper arms, to make that smooth. Yeah, there's already a video about twist bones, so I'm not going to show that here. So at that point, you're pretty much done with the rig. You can just do a bit of cleanup by maybe hiding the nulls if you want. I mean, it's highly recommended. Maybe adding those controllers to a group. Like if you have I guess I have all controls, so the animators can select all controls, not just the human IK controls, but all the custom controls as well. So all controls here. I also said we would organize all the constraints under folders. So maybe there can be a IK folder, an FK folder. If you want, you can do left side, right side, whatever. So in this case, IK left, rotation and IK, aim twist, parent, position IK. Basically all the ones that are active during IK mode, and the ones that handle the parent groups. So all these under IK, these under FK, together with those. And I have the relation IK FK switch, and maybe we can put all this into another one called well, wings or legs, whatever you're working on. Actually, I would probably put these under don't touch, unless there are some constraints that the animator should be able to animate manually for like activating certain space switching options. For instance, if you want, the behavior where the hand IK follows the rotation of the upper arm with an offset, if you want that to be toggleable, so the animator can keep the hand pin in well-spaced location, maybe you want to like expose this one to be at 0 here, and have it pinned like that instead of that. So that's really up to you. one other thing we can do is automatically display either the IK or the FK controls if we're in IK mode or not. So under the relation IK-FK switch, we could bring in all the FK controls. I'll just hold spacebar and right click here, select the entire hierarchy, receiver, same for the left side, receiver, and the IK controls, receiver. Let's play it right side and left side. For all these controls, we need to expose the visibility. So now the visibility just appeared here, and we can use the results from our IK modes here. So the result of the end nodes. So for the left side, we can drag those. Obviously, so challenging to keep everything readable. I can do it like that maybe. And do hide and connected. So same for the other side. Okay. And for the FKs, it's the opposite. So we can add a not node. Yeah, that's the right side. Boom, boom, boom. And I'll do the same for these left FK controls. Like so. So if I go back to master relation, when IK mode is on, I see only the IK controls. If I turn it off, I see the FK controls, so it's probably going to be easier for animators to know in which mode they are. Now there's a drawback with this. So currently I'm driving the IK mode. I'm forcing it to be on via the master relation, so it's always on throughout my entire timeline for all my takes. But maybe animators want to animate that property to be an FK for part of their animation, then transition into IK or vice versa. To do this, you would not force the value here, so you would remove this, and you would well, actually, let me start from IK. So selecting this, you would just let the animators be able to animate that value throughout the timeline, right? So right now, if I try to uncheck it, it comes back because it's forced by the master relation. So if I remove the value, I can toggle it on like this throughout time and animate with keys. But if I'm in FK mode, I don't have access to the IK control. Here on the right side, for example, I have no access to the hand IK on which our property exists. So it's like, from a user interface perspective, you would be stuck in FK, not able to easily go back to IK. There's a solution for that. It's reference properties. So let me just force it back like this. And I need to select both, like both the IK hand and the FK hand. So I'm going to do like a little shift click here. So I selected both. You could also use a schematic view, of course. And go to Properties Editor, Property References. So find on your IK hand the IK mode, select the FK hand control, and pass it on to it. Now, even if I'm in FK, I can select the FK hand control, and if you want, you can dispatch that reference on all the FK controls. And that reference property is exactly the same as the one that actually exists on the IK hand. So it's an instance of the property being stored on the IK hand. So if I toggle this, it's, you know, cascading its value to the relation FK just as normal. Okay, it's at 1, switch it off. It's at 0, take it, switch it on. And this corresponds to one and only one property in your F curves as well. Property references. So if I key it here, and then I key it there to set it at 0, knowing that, you know, a Boolean you can animate between 0 and 1. It's exactly the same, you know, whether you select it from the IK control or the FK control. So that's very convenient. And obviously it lets you do this sort of thing where animating in body part or full body here, I pose my limb throughout the timeline, animate any controller. Okay, so I have this little movement here. And on that key, let's say I want to switch to FK, so just toggle it like that. And I switch to FK and I can continue a few frames later. And here, switch back to IK. So it gives me this. I'm in IK, I go to FK, and now I'm in IK again, and it's all seamless. You don't see any pose pop, because the advantage of the system here is that the IK and the FK controls are always on the same spot. Either one is driving the other, but they're always on the same spot. Unlike maybe more traditional systems you might have seen where you can blend between the two, but blending implies having two hierarchies of controls. You would have like a hidden chain of bones that are driven by your IK controls, and you would have your FK controls like we have here, and the bones would be either 100% driven by the IK chain or the FK, and you could like blend in between if you want. But honestly, I don't really see the point of that, because then that means if you want to switch between one and the other, IK and FK, they are in two different spots, and that will create weird transitions in my opinion. So the model I propose here is a bit more in line with what human IK does, where you always have the IK and the FK working together, you know, not in different spots, and you don't know where your IK is if you're in FK because it's not visible, things like that. Of course, since it's custom, there isn't the magic of the human IK solver where you can seamlessly grab the wrist and move it like that, and then grab the upper arm and rotate it. You have to manually switch with the Boolean, but I think it's a good base for a solid. But I think it's a good base for a custom limb, and you can obviously expand with more space switching options and things like that. And just one last note about the pole vectors. So personally, I like working that way with just the twist value. I find it way easier than dealing with XYZ. But if for some reason you want to have that pole vector exposed like a traditional Maya Blender rig, I mean, I could see the use if you have to have that elbow like kind of pinned in position somewhere, just like with human IK you would with IK blend translation. So if you need something like that, you can always make another set of objects where you would have a null like this, which would be like group parent pull vector left, for instance, and have a marker as like a pull vector controller, which would oh, let's put it in blue. So that one would be parented to this one, and that one maybe would be here by default. So you see my little blue control here. And what you could do is a space switching, where by default it would be parent constraint to the pull vector that's just a child of the twist. Okay. That way when you rotate the twist, it would follow along, kind of like this. And then with a space switching system, with which I presented in another video, you could change that so this pull vector would be in world space, and therefore it would just be on its own, and the twist would not influence it anymore like that, and you would just move that along to drive the pull vector. So I guess you would make your IK, you would make the pull vector be the new controller you've created. So you can drive it like this in world space, but if you do a space switching system, it would just rotate around this object. So that's totally doable with the system. I think you have all the knowledge now to set that up if you want. Thank you very much for your time and watching the video. I hope it was useful. If you have any question, as always, let me know. Cheers.